the headset works as well.
Check 1 2 1 1 2. Check 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 check. Check 1 2 2 2 1. Check 1 2. Check 1 2. You're good. Well,
You good to go, Capcom? Well, good evening, ladies and gentlemen, and welcome to the July Recreational Astronomy Night at the Royal Astronomical Society of Canada's Toronto Centre. We're here at Studio 2 at the Ontario Science Centre. And I'd just like to quick question, is anyone here for the first time? Any new members? Anyone? Okay, welcome. So this is one of two types of meetings we hold here at the Science Centre, our Recreational Astronomy Nights, which are talks put on by the members, and we also have our speaker nights in which we have a professional member of the astronomical community come on in and talk to us. And so tonight we've got 3 presentations lined up. We're a little pressed for time this evening, so unfortunately we're going to have to cancel the questions afterwards, just to keep things rolling. So we're going to start off. David Makepeace will be talking about Still Hooked After All These Years, Confessions from a Lifetime of Chasing Eclipses. David.
thank you, Tom. I can't tell you how pleased I am to bring this film to the Toronto Centre of the Royal Astronomical Society tonight. I'm not going to speak for very long so we can actually get to the film because we are a bit short of time, but one of the things that has excited me the most about my interest in amateur astronomy and in eclipse chasing is getting out and talking to people about it and spreading the word about the cosmos that we live in. And after I saw my first total eclipse of the sun in 1991, I was gripped with this need to start filming them and creating content so that people could understand what this event actually was. And around the year 2000, I made a documentary film called Hooked on the Shadow, talking about my adventures in the 1990s running around the globe to see total eclipses of the sun. And I decided that prior to the big eclipse in America this year on August 21st, that I wanted to show that after all these years, I'm still hooked on this experience and how important it is for me to try to explain to people what an incredible moment totality is. And for me and for many others, what a life-altering moment a total eclipse of the sun can actually be. So Still Hooked is a 20-minute program that shows off some of the eclipses that I've been on and some of my attempts to capture them and film them, and how it's completely changed my life. So please enjoy the film.
me I wouldn't go to all this trouble if it wasn't worth it. But it is. I'll do anything to be in the moon's shadow, even for a few seconds. Even if it means booking a special eclipse flight to the top of the globe. In March 2015, the long, thin shadow of the moon carved out a path toward the North Pole on Earth, and eclipse chasers flew right into it. At the precise moment, the moon projected its shadow onto the Earth, and I watched it swallow our plane. The alignment was perfect. It was a huge challenge to film, and it didn't all go as expected, but I spent over 3 minutes in totality, and the rest of my life with a new sense of the three-dimensionality of the solar system. These moments were among the most exhilarating of my life, and more than just a little reminder of what Carl Sagan was talking about, that we are all flying through space on a rock. If I had a bucket list, it would simply say total eclipse. Eclipses have taken me everywhere, like Australia in 2012. This time, the path of totality swept through North Queensland and dozens of coastal villages. We had to book this place 3 years in advance. But when we arrived, it was cloudy every day at eclipse time. As serious eclipse chasers, we knew it was too risky to stay at our beach house on the coast. If we wanted clear skies for the eclipse, we had to run inland.
So the models are suggested like this tomorrow, or are we moving?
The Jamesboro Lookout was a 3-hour drive into the tablelands, and it seemed like a perfect location. Sometime between now and August, you have to decide, am I really going to miss this? Whether it's the desert in Libya, the border between China and Mongolia, or any one of dozens of other remote locations, getting to film on every continent chasing eclipses has been a pretty cool job, and it ain't over. Just give me totality, a few cameras, and a trip around the world, and I'm a happy guy. In South America in 2010, I kicked around Peru, hiked the Inca Trail to Machu Picchu, and took the train to Cusco through the Peruvian Altiplano. Pointing my lens at eclipses has taught me how to be present for the rest of the world, too. My camera helps me focus my attention on whatever is unfolding in front of me, and then I just let it roll. It's a rush I can't really describe, and it's helped me notice details about being here in the solar system in a way I never did before. I made it down to the tip of Argentina for the eclipse and up into the mountains.
The sky was clear and the air was frigid. And there was lots in front of my lens, with fellow eclipse chasers I've seen over and over again at locations like this.
That's cool. We got like what?
When the shadow of the moon swept across us, the eclipse dangled in the air above the peaks of the Andes like a jewel box had tumbled open in the sky. It seems funny to say after all of these years filming, but totality is so amazing it can't really be caught on film. No photograph, no video could ever show what your eyes can see without even trying. You really do have to see it for yourself. And this summer, you can pick from over a dozen states. Take a look at what the solar system is doing. As the moon moves in its orbit, its shadow narrowly misses the Earth most of the time because the alignment isn't perfect. But during a total eclipse, the moon's shadow does touch the ground in a very predictable way. These are the celestial mechanics of eclipses, and another reason why they are so incredibly exciting to chase. The arrival of the moon's umbra signals the alignment of the sun, the moon, and the Earth, and creates the conditions for a total eclipse of the sun for everyone in its path. Chasing an eclipse, you put yourself on a collision course with the solar system. These are the North Maluku Islands in Indonesia, a chain of volcanoes in the path of totality, and I'm here to see another total eclipse. And just like every eclipse I've ever been to, it's the main event around here. But with 18 hours to go, weather once again forces a last-minute change of position and we run. We need to stay inside the path, but we can't stay here. We pick a location at the southern tip of Tidore Island. For the filming, it's got everything I need. Great views, palm trees, lots of friendly faces, and plenty of solar system in front of my lens. When a local family learns we've come to share the eclipse with them, they insist on putting us up for the night.
How you doing? It's just me and 37 children.
Yeah.
We get a home-cooked meal and a full helping of Indonesian hospitality. All we need now is clear skies in the morning. It rains all night. I don't sleep. But at dawn, the sky begins to clear.
Here it comes.
The sun will be in total eclipse in less than 3 hours.
Dave, how you feeling?
It rained overnight, but it's stopped now. So that's the best we can hope for right now, and then we'll just see what happens over the next couple of hours, if we get it or not.
I'm setting up my camera gear like this. 5 cameras. One for a close-up of the sun. Another for Lucas and I. And 3 wide-angle shots, each designed to film the action of the shadow being projected through the sky and onto the Earth. What I've learned is that even though it's impossible to capture the corona in a single shot, I can show the effects of the eclipse on people and the Earth. The transformation of your environment is a big part of the total eclipse experience. It begins when the moon makes its long-awaited appearance. A tiny bite out of the sun starts the clock ticking. For the next hour, there is a tension that eclipse chasers thrive on as the partial eclipse deepens and the anticipation of totality completely takes over. In what seems like only minutes, the moon has blocked the sun to a sliver. The air is cooler and the wind picks up. Then all of a sudden, the light starts to disappear. The shadow of the moon has arrived.
Moving at over 2,000 miles an hour, the shadow has been creeping closer and closer to our location here. From the ground, the arrival of the moon's shadow is chilling. Watch this time-lapse again. Keep your eye on the sun as it gets pinned by the moon. See the shadow advance across these clouds, then darken the horizon. The eclipse is a cosmic light switch. Daytime into night in a matter of seconds. On camera 4, you can see the leading edge of the moon's shadow in the sky. Total eclipse on this side, not quite yet over here. This eclipse delivered some of the most dramatic images of celestial mechanics I have ever seen. Camera 1 really pays off. Moving this way, the leading edge of the moon neatly tucks away the last sign of the sun in the spectacular diamond ring effect.
Yes! Yes! Whoa! Woo! Oh my God! That's fantastic. Woo! Prominence at 8.
Venus, Mercury, total eclipse of the sun.
The great coincidence is that the moon is exactly the right size.
Look at the beautiful sky.
I know.
Oh, just fantastic corona, asymmetrical.
I knew it at the time, too, that the filters I was using helped me get great detail in the middle corona here. And with the palm trees gently brushing up against the corona, I couldn't ask for more.
Oh my God!
Outstanding.
Look at it! Oh my God, look at it! It's amazing!
Oh my God, fantastic coronal streamers.
Yeah.
The one at 3 o'clock is massivo.
I'm lost for words.
Oh my God, it's fantastic corona. Look at all the detail.
I know.
Look at that detail.
Yeah. Oh my God.
That one huge fat prominence.
Even though this eclipse lasted over 3 minutes, it seems like only 10 seconds before the trailing edge of the shadow appears and brightens the sky again. Totality is over.
Oh, it's starting to get hot on top.
Yeah.
Oh,
there
that's
it is.
it. There's a diamond
There's a
ring.
diamond ring.
Whoa! 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 Oh my God, fastest 3 minutes ever. Fastest 3 minutes in the world. Oh, shadow going. Oh!
As the moon moves off, watch the emerging light from the diamond ring spill down and relight the Earth. And then this sway of the palms modulating the sunlight escaping from behind the moon, allowing us to still see the black disk. To my knowledge, nothing like this has ever been filmed before.
Number one, my God. Number one. Very good. Fantastic. I love this.
Thank you.
With such intense interactions with our world, I can't help but be different now. And I think this is what Carl Sagan was really talking about. Being reminded that everything in front of my lens, everything you are seeing here came spilling out of the Big Bang. This is what the Big Bang is doing 14 billion years later. This camera came out of the Big Bang. My eyes, these thoughts, all these people, everything is bits and pieces of universe raw materials. And that includes you sitting here watching. And it's all made me realize that we too are the universe. It's the universe that makes total eclipses, and it's the universe looking back at them as well. Once I realized that it was also the universe doing the chasing, that I wasn't just dropped into the scene from somewhere, that I was an inextricable part of the phenomenon I was witnessing, the eclipse became something more. A powerful symbol of how I and the universe are one and the same. This one realization, the most important of my life, might not have been possible without the eclipse experience. An event so intensely cosmic, it has the power to make you think twice about what you might be. You only have to see one total solar eclipse in your life. A lot of people I know think they've already seen one, but this could be your only chance to see it for real. For North Americans, this is the most accessible total eclipse in decades, and the best place to see it is inside the path of totality. From Oregon to the South Carolina coast. Just pick one of these states and go there. And you're going to need eye protection. Learn to watch the eclipse safely by watching my other videos and downloading the information flyers from these websites. And never look at the sun with your naked eye. All the information you need is already out there, and there are detailed maps of the path for each state. Learn where the shadow will fall and make your plans. The eclipse on August 21st could be the most observed in history as millions of us gather to witness totality together. It's one of those things you don't want to miss. But don't take my word for it. Come see for yourself. Experience the greatest spectacle on Earth and be present for the universe the way you've never been before, inside the path of the shadow.
Okay, David, thank you very much for the presentation. Wonderful video.
Thank you.
So, next up, we've got Frank Dempsey, who's going to be giving us an update on the current solar cycle 24. Frank?
Hey, thank you. So this is started register.
1 second, I just gotta give you a response.
We're all going to be a 10-minute. Pretty sunny here, Tom.
We need to see.
Actually, I'm not talking with the next guys.
Just loading.
Yes. So we all set now? Okay, thank you.
Hang on.
Hang on for Okay, so I'm extremely glad to be here to share with you some stuff I find interesting. And so I've been studying this stuff for years and try to keep up on the research, but I'm still hooked on solar cycles. So keeping this as brief as possible. So just stop here, this first slide. Here's the solar cycle 24 on the right-hand side there. And it's quite a bit lower than the previous cycle. And that's basically the update.
Is your microphone on?
Just switch. Looks like it's switched on.
Yeah.
Is that better? Okay. Okay, so in that case, I'll bump on to the second slide. So I'll just, I thought I'd talk about a few details I try to throw in some order here, but I'm keeping it brief, so I'll skip over here as quickly as possible. Mainly sunspots and some cycles and a few other little details. And so if this advancer works, if it does, if you can advance to the next slide, that'd be really ideal too, since this doesn't work. Okay, so I just didn't know how much I ought to say about sunspots, since most people are quite familiar with it, but so they're quite visible in a small telescope, and the right-hand image there gives the impression of through a small telescope that you could see, even with these eclipse viewers glasses, a big enough sunspot would show up visible to the eye without a telescope, and a nice sketch on the bottom left there. So a lot of details about sunspots that I won't dwell on too much. Was it the bottom button here?
We do want the laser?
No, I just want to try to advance to the next slide. It is this bottom switch, correct?
This one under the way up, yeah.
Okay, so there's quite a lot of details on any particular day in the sun, and this particular image shows a few more details than you would see by looking through a telescope. But so this is about a week ago, and here's some sunspots as well as coronal holes and a lot of other interesting features on the sun, which I won't dwell on. I'll just mention that between solar maximum and solar minimum, quite a difference in the number of details that are on the sun and active regions especially. So keeping it brief to minimize dwelling on any particular detail, some sunspots are caused by magnetic fields, and so magnetic fields suppress the upwelling of fresh material, and so it's a relatively cool spot that appears dark. So some cartoon here is a pretty good explanation. If we dwelt on it, we could explain more details. And speaking of more details, there are quite a bit more details if you want to look into it. So sunspots by themselves are pretty darn interesting. But the main point is they appear dark, and I think all that matters for the presentation here is that I'm talking about numbers of sunspots that you would count. And so if we count them each day and plot them each day through the month, we'd get a graph sort of like this for June last month. And so quite a variation from 1 week to the next. And so there's about half a dozen of my observations in this one here, but this is compiled by the AAVSO solar section, and quite a variation. And main point is that when you compile these into weekly or monthly numbers and then compile them year by year, you get quite a periodic variation showing up. And this is the past 17 years. So you see cycle 24 is on the right there, second half of cycle 23 is on the left, and you see at a glance that there's quite a difference in the size of the cycle. So just at a glance, cycle 24 is quite a bit weaker or less intense than the previous few solar cycles, or at least cycle 23 that you see on the left. Also, within any particular crest of a peak, there's ups and downs and variations, and cycle 24 was exciting by itself, just having a double peak. So it's a very new science. Just when people thought they understood solar cycles, this cycle 24 is really throwing a curveball or quite a surprise. And so, if we look at other details, we can plot other details, and you may or may not see the yellow lines, and they don't show up very well, but there's daily plots of solar intensity. And so solar intensity varies quite a bit. So does 10.7 centimeter radial flux and solar flare index. They all vary with the solar cycle along with sunspots. And so quite a lot of variations. I'll show a few more a bit later, but not to dwell on too many details, the sun is very interesting with this output varying quite a bit. Now that's all relative because you see a difference of, on the left-hand scale, 1 watt per square meter over about 1,366. It isn't really a lot, but it is. In some sense, it's quite a variation. So if we plot even longer time scales, in this case back to 1983, a 30-year period, we see several solar cycles and quite a variation of top graph shows sunspot number, which I was showing you earlier. If we plot cosmic rays, we see that they're different because at a weaker sunspot cycle, more cosmic rays from the background galaxy can penetrate into the solar system. And the various cosmic ray and neutron monitors around the world can measure these and pick up a periodic cycle as well. There are more that can be measured by satellite X-rays, ghost proton events that ghost satellite, which is well outside of Earth's orbit, and solar wind details. and various other details that all cycle with solar cycles and change quite a bit. Here's an example. I threw in this chart to show on the top, anyway, solar wind speed. And this is sort of relevant. You see with the solar cycle plotted in the dashed lines, you see that near the peaks of the solar cycle, shortly after that, a few years after that, is a peak of solar wind speeds at Earth. This is some relevance if you like to watch aurora, and you see that there's quite a few disturbances on the downside or second half of a solar cycle. It's because solar winds or wind speeds are faster than. Anyways, loads of interesting details just in this one picture, which I won't dwell on. So if we plot a few more cycles, you see that in relation to the past 2 cycles, we're really in a downgoing trend from past 20 to 30 years with several solar cycles plotted. You see quite a big difference from the huge cycle in 1991, a major solar maximum period we had then, down to the current solar cycle. Quite a strong trend. So some people plot how does our current solar cycle, although it's very unusual, compare with some past solar cycles, and it looks like it's fairly similar when they plot it with cycles that happened nearly 100 years ago. And so you see, along with the double crest of the solar peak and the several cycles that it's familiar with, people try to use that to forecast what will happen next, because it's basically unforecastable at this point. At the start of cycle 24, people were trying to forecast and predict how long this would last and the strength, and some predictions were for a very strong solar cycle 24. Others were for a weak one, and you can see it's turned out to be a weak one. Plot at longer periods, you see quite a cyclic variation, and you see over several hundred years, you can probably pick out several different cycles. There's a Gleisberg cycle, as it's called, around 90-year cycle, and another cycle that's around 220 years, so-called Sioux cycle, and we trends. I think I have one here. It's a similar sort of plot. Again, the past one has been being referred to now as a grand maximum, and you may be familiar with the Maunder minimum that occurred back around 1600s when sunspot observations began with Galileo. And there was a period of very low sunspot activity for quite a few years. Another period called the Dalton minimum. The main point of this presentation that I find very interesting is that nearly all solar astronomers now agree that we're heading toward another grand solar minimum, as it's called. So a grand solar minimum is following this grand maximum, and looks like we're headed into a period of very low solar activity in the next 50 years or so. Let me bump it ahead. I think I had a longer period. This just shows a different perspective of how we compare with this current solar cycle 24 with some past periods. But again, you can see that there are some cyclic variations in very weak solar cycles and very strong solar cycles in the past hundreds of years. Here's a plot of 11,000 years for the sunspot number reconstruction. You can say, you could argue, who was watching sunspots 11,000 years ago? And nobody, of course, but hopefully nobody. But it's been reconstructed with cosmic ray isotope, beryllium isotopes, and P-ring data that have been found to be fairly reputable for estimating sunspot numbers. So you see at a glance where we are on the right-hand side there. It's been much stronger in the past, and also has been fairly weak at some years and some periods in the past too. Butterfly diagram, quite a lot of detail here. I think I'll skip it due to time, but basically it shows at a glance that if you pick any one solar cycle, the minimum of the cycle coincides with the start of a new cycle, and sunspots appear, you see on the left-hand side of any particular peak, they appear at higher latitudes. Around 30 degrees latitude on the sun is relatively high latitude, and as the solar cycle progresses, the sunspots appear more and more at equatorial latitudes. And also plots the area too, so you may be able to pick out the area marked off in the top right, but it doesn't show up very well here. But it's a nice effect butterfly diagram, as that's called. One other detail that's really worth dwelling on to for a moment at least is the solar polar magnetic field strength. And this has been measured since about the 1970s, since magnetograms were fitted on certain observatories, especially at Mount Wilcox in California, for measuring the polar magnetic field strength of the sun. And so the point here is that they've been gradually decreasing. So you see several solar cycles, and the polar field strengths have been gradually decreasing. And this is one strong piece of evidence why solar astronomers are now convinced that we're heading into a solar minimum, a grand solar minimum. And if I get this to advance to the next slide, if it decides to work, we'll see that the, well, we might be out of luck. So there are a few other details I didn't want to dwell on too much. There's a lot of other details. In this case here are some papers about the sunspot cycle coinciding with interheliospheric turbulence levels measured in solar plasma and chromospheric emission, also leading to the same conclusion. And this one was about, somebody put together a forecast for the next 500 years. And so there are two forecasts here. One's in the darker gray, one's in the fainter gray. If you can see it, I can barely see it from here, but depending on how somebody manipulates statistics and bins averages and so on. But one point is that they seem to be fairly convinced that we're heading into a strong minimum for about the next 50 years. And then after that, could it recover for the next 500 years or could get even lower, according to these predictions. So I thought that's a little interesting because that's also fairly well accepted now by most of the solar physics papers that I see every day. And so here's another paper which I won't dwell on due to time. So I could say, is there any use for this and who really cares? And it's a good question. Does anybody here care? Good, glad to see a few people care. Yeah. So it's pretty important because it connects with the Earth. And so magnetic fields connect with the Earth. And a lot of details here which you can look into because it's pretty interesting. A lot of effects on planet Earth and a lot of commerce gets strongly affected by solar activity. So I won't dwell on any of these. I'll just finish off pointing out that sunspot numbers are pretty interesting and they're the basis of the cycles that I've been pointing out. And so I know this year, especially, a lot of people are getting some solar telescopes. And so, so I say, from what source? And these come from observers. And so, can you contribute? So I'm finishing off with this one little detail that you can, if you want, contribute to this. And so, the AAVSO is one group, solar division. There's other groups as well that compile sunspot numbers, but it means that amateur astronomers can go and view the sun every day that they have, and a few days a month or a few days per week, and count sunspots and submit them. And collectively, these can be combined to form the official sunspot numbers. So there are a lot of people with pretty fancy equipment who may not use it anymore after August, unfortunately, possibly. So, but it could be put to use, and people might find it really, really interesting looking at the sun every day just to count sunspots. And so to do that, if they want to contribute to the AAVSO, if we get to the next slide, which would be, I think, the second last slide, so if it doesn't want to work, I'll just have to talk about it. So the point is that to contribute sunspots to the AAVSO, as one example, there's a manual online for how to do it. So there's a good little technique for how to follow certain procedures to contribute sunspots that will be countable toward official sunspot numbers. So this is a free downloadable guide that you can check out. Anyway, I finished off that little detail about how you can contribute if you want to. So to finish off, I've skipped a lot of details, I know, but we're keeping it short on time. So I'm just finishing off by saying again, there are a lot of interesting trends going on, and it's still ongoing, interesting every day. And this final solar cycle that we're in right now is really full of surprises, and it's worth studying see if we really do get into a grand solar minimum after this current solar cycle ends around the year 2019 or 2020. We'll see what happens then. So I'll keep following it. Okay, thanks for your time. All your stuff.
Thank you very much, Frank. So our final presentation for the evening is Peter Hiscox. Peter is the head of our Light Pollution Abatement Committee, which is why he gets the great title of Prince of Darkness. So Peter's going to be talking about the new City of Toronto guidelines on lighting and other developments in light pollution. Peter.
Okay, thank you, Tom. All right, let's wait for the technology to catch up here. Yeah, you have to be careful where you mention the term Prince of Darkness. It means special things to certain people. So this is about what's been going on in light pollution. Myself with other people as well thought I would bring the group up to date. And the clicker doesn't work. Let's see. No, next slide, please. Okay, back one. There we are. Okay, so our first project to talk about is contacting the municipalities. I like to say, as far as lighting salespeople are concerned, they are many, and the light pollution people, we are few. So there's a tremendous effort going on in the lighting industry to sell street lighting to municipalities. Some of it is not very good lighting, and so we undertook a project to contact all the municipalities in Ontario to give them a bit of a heads up on this. There are 424 municipalities in Ontario. Even getting a list is a bit of a struggle because the Ontario Association of Municipalities want $800 to give you the list. I managed to get it out of the Ministry of the Environment, dock them into giving us one for free. And Allard helped me set this up, the spreadsheet with the names and email addresses, and then we worked our way through them. About 150 have converted to LED street lighting, and I know of at least one case where the early adopter now has buyer's remorse on what they installed. It's excessively bright, and they don't have control over being able to dim it, and the color temperature isn't that great. So LED lighting is not a cure-all, and we hope to head off some of this at the pass by notifying people on this. Next slide, please. And this is a list of all the municipalities. I had no idea that there were all these municipalities in Toronto, all the way from Addington Highlands down to Zora. Have you heard of Zora municipality? So there they are. We worked our way through all of them. It was a bit of a slog actually doing this, and Allard helped out with some of the grunt work. Okay, so next one. So project number 2, monitoring sky glow, and the Toronto Centre purchased 2 sky quality meters from Unihedron, and we installed one of them at the Carr Astronomical Observatory up in Collingwood, which is the rural location, and the second one at the David Dunlop Observatory, which was the urban location, with the idea that we could compare sky glow at a rural location and an urban location. Of course, we lost the DDO when it closed, and that's been in limbo. In the last week, I've been talking to Rachel Ward-Maxwell, our contact here, and we had a tour of the Ontario Science Centre, and so it's looking up that we may be able to install a second one actually overhead here at this very location. Next slide, please. So there's the Carr Astronomical. This little cylinder on the right-hand side here with a window on it is the actual light meter, and that next slide, please. And the cylinder at the top of the pole at the David Dunlop Observatory, and of course that one has come down since. And the next slide, please. And then this is the Science Center, and if you see the radio antenna at the top of the highest point on the building, we were up there last week scouting locations, and that's a perfect location for mounting the sky quality meter. The possible fly in the ointment is that we have to pay for the installation, so we have to pay for lightning arresters, and I hope that's not going to be too terribly expensive. Anyway, that's underway, and I hope we'll be able to report a success in that particular area very shortly. Next slide, please. This is the kind of result that you get from a sky quality meter. You get a graph with various readings. If you're familiar with the kinds of readings that you get from a sky quality meter, a value of 18 is typical for Toronto, a highly light polluted area, and a value of 21 or 22 is a pretty pristine dark sky, which is out around Collingwood. Still pretty dark out there. So we hope to, Allard again is helping me with this, and we hope to have these graphs accessible to the public in the fullness of time. All right, next slide. Okay, so project number 3 was the producing a document with the City of Toronto called, originally called light pollution, something about light pollution, but it's now called Best Practices in Lighting. And this is the cover of the document. It's available to download from the RASC website. So you can download it, read it. It's in a large PDF, which is available to you. Next slide, please. So the history for this is kind of amusing. It started in 2007 with a committee of 16 people. And as time went on, the city does not move quickly on these things, I discovered. And as time went on, the committee dwindled down, and finally it was finished this year with a committee of 2 people, which was me and a person from the city, plus a photographer, Gabriel Guilin, if anybody knows Gabriel, who did the photographs. He's a member of the RASC, the Toronto RASC. 80 pages long, hundreds of images. We went for something that is really interesting to look at and has kind of the flavor of a National Geographic type document with full color and so on. It's available at this particular location on the RASC website. Next slide, please. Okay, so what we have is an introduction by a famous person. And Chris has written a very nice introduction, of which this is an excerpt, and he talks about the fear of the dark, and I think that's absolutely spot on. And there's some pictures taken from the International Space, that he took from the International Space Station, that are in the document of Toronto, okay? And he signs himself as a Torontonian, okay? So, which is very, very nice. Next slide, please. All right, so what has this document accomplished in this 10 years of meetings with the city? It doesn't mandate anything. It doesn't say you have to do anything, but it does make a number of recommendations. And I hope that eventually these recommendations will turn from you should do this to you must do this. So this is a process, and we're partway along that process. The things that should be controlled are, first of all, light trespass, which is light that shines onto your property from somebody's adjacent property. And the recommendation in the document is 1 lux at the property line, larger of a horizontal or a vertical measurement. This is important because traditionally light measurements are taken horizontally, and often it's the vertical measurement which is more intense than horizontal. So 1 lux at the property line is pretty strict. And so far, no pushback on that. So, and that's an example of light trespass, by the way, from the Parking Authority of Toronto into somebody's bedroom. All right, next slide. The next one is glare, which is really not well addressed by the lighting industry at all. They really haven't dealt with the issue of glare, and glare has become a major, major problem with LED lighting, because the LED lamps inherently have very high glare factors. So I have suggested that the glare, the limit of glare, limit of brightness on lamps should be 1,500 candelas per square meter. The candela per square meter is also known as a nit, okay? So you can call this a nitpicking exercise if you like. 1,500 candelas per square meter, just to put this in context, is like looking at a 60-watt light bulb. A frosted 60-watt light bulb is about 1,500 candelas per square meter. And you can look at it. It's not terribly comfortable, but you can look at it. LED lighting, I've measured LED lamps at over 1 million candelas per square meter. So it's, you know, they're horrifically bright. And I think we need to control this. And this essentially says, you cannot have something that's brighter than this where you can see the surface that's emitting the light. All right, so I hope this is progress, and I hope that eventually this will be made into a requirement. Next slide, please. All right, overlighting. Anybody recognize this particular site? This is the dealership at the bottom of Broadview and Eastern Avenue. What are those called? Minis? Yeah, it's a mini dealership. Anyway, typical street lighting level sidewalks in Riverdale, where I live, is around 3 or 4 lux. An intersection might be 20 lux. The sidewalk outside this particular location measures 800 lux in sidewalk. So this is, and car dealerships are the worst because they get into lighting competition with each other, and who can who can produce the most light. This dealership is visible in photographs from the space station, all right, on an image of Toronto. So I'll talk a bit more about what can be done about this kind of thing, but obviously the document says, gee, guys, this isn't a good idea. All right, next one, please. Next slide. Then there is the issue of health. This has been huge. The American Medical Association, the president of the American Medical Association, turns out to be an astronomer. And the American Medical Association came out with a statement on LED lighting which echoed what a number of researchers had been saying, is that blue light at night is harmful to your health. And when it came out from the American Medical Association, everybody started to pay attention. And so the issue of color temperature in lamps became a big issue. Many LED lamps have a lot of blue light component and are at 6,000 or 5,000 Kelvin. And this recommendation is that light should have no higher than 3,000 Kelvin. And that's had a dramatic effect on street lighting installations. And nearly everybody now is mandating 3,000 or below. I can talk more about health and exactly how this impacts people, but the main takeaway is sleep in a dark room. Don't sleep with the lights on. Don't sleep with a TV screen or a computer screen running. It affects the melatonin suppression, and it may affect your health in the long run. All right, so now I have some pictures of what I think are interesting lighting installations, both good and bad. So this is the viaduct, and this is the suicide barrier on the viaduct, which is lit up at night with LED lighting. I was originally strongly opposed to this whole installation. But I have to say, now that I've seen it, it's an amazing lighting installation. There is no glare from this thing at all. Notice how uniform the sidewalk is. You have to ignore the street lights. But along the sidewalk, it's completely uniform. There is no glare. There's no light shining into your eyes. It's a really interesting experience to walk across the viaduct in this light. It's really comfortable. And you realize how uncomfortable most existing street lighting is, because it goes from bright at about 30 lux down to dim at about 4 lux. So you're continuously going in and out of dark and bright spots, and you're dealing with the glare from the lamps. So it's a totally different experience. I recommend it. Some summer evening, walk across the viaduct. Next one, please. Okay, there's a bad one. Riverdale, my neighborhood, of course. And there are hundreds of these all across the city. Rinks, ballparks, you know, middle of the night, nobody's there, everything going full tilt boogie, right? Lit up like a prison yard. Okay, the Parks and Rec say, oh, well, you know, people ask us for this for security. I mean, who's going to do a mugging in the middle of the rink in Riverdale? It's insane. Anyway, I'm working on it. Okay, next one. Been down to the distillery lately. Very, very nice street lighting in the distillery. Does not shine in your eyes. Generally directed, as you can see here, directed to the walls. Even the light poles along the street, which could shine into your eyes, are run at such a level that it's not obtrusive. Very, very pleasant to go down there in the evening. And I think the lighting is a big part of that. They've been very, very good about their lighting. Next slide, please. Here's a bad example, and this is thousands and thousands of streets throughout Toronto. Actually, 165,000 light fixtures in the city of Toronto, all like this, that, you know, off into the distance. And this is how you can tell they're not shielded, because as you stand there, you can look sometimes, some cases for miles, and you can see they're all lit up, right? And the fact that you can see it from several miles away means it's not properly shielded. And I'll show you a counterexample in the next slide. Okay, and this is in Markham, and notice that as you look off into the distance, the lights disappear, right? They disappear from view. Not totally, you can still see them, but they're not as bright as they were in that previous photograph. And that means that the lights are directed downwards to street level, as they should be. All right, this is a new installation. This is an LED installation, and it's actually pretty good, I gotta say. So it was nice to see. Next slide. Okay, now project number 4, last one I want to talk about. This is not mine. This is by somebody else, Robert Dick, who is in Ottawa, and he's in the national version of this committee. He's the chair, and he has developed a light, which Robert is involved in something called scotobiology, and scotobiology is the biology of things of the night. So it's the biology of bats and fireflies and other living things that come out at night. And living things are affected by the light on the left. As we all know, insects are attracted to those lights, and that's one way they're affected. But there are all kinds of effects on the environment from that kind of light. And Robert developed an LED lamp, which does not have glare, which is at a better color temperature. Notice that the one on the right is kind of an amber color as opposed to the bright white, and is directed downward so it doesn't shine into your eyes. And it's a clever optical arrangement as well, so the LEDs are hidden. Next slide is another picture of this. And here is a roadway that is lit up with these fixtures, which to me is just an amazing picture because the roadway is lit and you hardly see the fixtures at all or any glare from the fixtures. And I've actually attended a conference where Robert was demonstrating this fixture, and it's an amazing experience to be underneath one of these fixtures because it's like you could read just fine. It's like reading by candlelight. It has a very warm, comfortable feeling. There's no glare, and it works very well. So Robert has turned this into a commercial product, which he is now advertising on his website. So you could look that up if you are interested. And then I think the final slide. Yeah, so here's where you come in. There are a bunch of things that you can do. I know you're interested in astronomy, and for some perverse reason, I'm interested in light pollution. And I don't expect you to spend a lot of time on light pollution, but there are some things you could do that would really, really help me and the other people who are working on light pollution, which incidentally, the number of people in Canada working on light pollution, you could count on 2 hands, right? It's about 6 or 7 individuals like me, like Robert, and so on and so forth that are working on light pollution. This is against hundreds and hundreds of people in the lighting industry who are working in the opposite direction. So here's what you can do to help us. First of all, if anybody has any contacts at the Ministry of the Environment, I think one of the things we should do is go to the MOE and say, you know, those 443 municipalities could use some guidance on the design of their street lighting, and you guys should provide it. So that's something that can be done if anybody has a contact at the Ministry of the Environment. If you see a good lighting installation, you think, yeah, this is really nice, or gosh, this is terrible, photograph it, or send me an email saying, go look at this. This is really horrible. Or even better, go and measure it and tell us how bad it is. All right? I'm interested to hear about these things. That's how I heard about Markham. Paul told me about that. He said, go and look at the ones in Markham. So I did, and indeed they are very, very good. Contact the owners of bad lighting installations. If you see a really lousy lighting installation like that car dealership I showed you earlier, write to them. Some of the people respond in a very positive way, and they say, gee, I just had no idea that this was a problem, and so on and so forth. And you get somebody on your side who's going to help you fix that problem. And the last one is also very important. One of the things I do is go and speak to groups, professional engineers and schools and that kind of thing, Boy Scouts and so on. If you know of a group, an environmental group or a group that would be interested in a talk on light pollution, is a very important educational function because most people don't know anything about light pollution. And when you explain it to them and you just say, well, it really is bad design and lighting, and if you do good design, gee, we might be able to see the Milky Way over Toronto again as we could up until 1985. You know, people respond to that. Well, let me ask an interesting question here. How many people here have seen the Milky Way? Right? Everybody. You know, when I ask this question in a high school or in a university class, I get maybe 2 out of 20 people that have seen the Milky Way. Is that not a tragedy? Is that not a crisis? I think it is. So this is why we have to speak to them. We have to say things like, go to a dark sky site and look up. Somebody said to me, do we need a telescope to see the Milky Way? I say, well, you just need your Mark I eyeball. Okay? So if you know architects or you know environmental people active in environmental organizations or whatever, tell me about them and I'll contact them and I'll set up a speaking engagement and we'll spread the word on this. So thank you very much. That's your update for this year, and we'll be back. Tom, we're ahead of time. I know. Do you want to entertain questions?
Well, actually, yeah, Peter, we are sort of running a little ahead of schedule, so does anyone have any questions? Yes,
I'm a visitor.
Yeah.
Peter, can.
I spent 23 years in New Zealand.
Yeah.
And the town of Tekapo in the Mackenzie region actually has regulations for lighting. Right. It was prompted by the Mount John Observatory, but they now have a major tourist attraction. People from all over the world, especially Asia, especially China, where they cannot, I work in China, I can't see the stars. And they go to New Zealand, and I've seen, not just the Milky Way, I've seen the Magellanic Clouds lying in the backyard of the town of Twizel, which is just a little ways down the roads from Tekapo. So it's just fantastic. And they actually have an international quality lighting control system like this. Everything's downward, everything's shielded. They don't, 3000 K. They are the epitome of this kind of thing.
One of the things that the National RASC Light Pollution Committee does is establish dark sky preserves. So these are parks where dark skies are particularly preserved across Canada. So that's sort of in the same direction.
Absolutely.
But I was asked in a meeting by the director of street lighting for Toronto Hydro. She was kind of incredulous about this whole idea of, downward lighting and so on. And she said, "You really think that we're going to be able to see the stars from the city of Toronto again?" And I said, up until 1985, we could see the Milky Way. So, we're facing a number of environmental issues, global warming, for example, which are these are big things. But light pollution is relatively trivial and relatively easy to fix. That's the good news. We just have to do it. Yeah, okay. Any other questions? Yeah.
In reference to that AMA advisory on LED lighting, would it be useful to contact the Ministry of Transportation about the LED lighting in cars? Yes. A lot of new cars have these horrible bright LED lights, which is very uncomfortable to drive against.
Yes. Yeah, I know people my age who stop driving because they can't deal with the glare. Yeah, no, you're absolutely right. Yes.
Headache inducing for sure.
Anybody want to pick up on that?
Contact Sylvania.
Yeah. Chris?
Do you have any sample wording or text or templates that people can use to approach businesses or even their neighbors in a respectful and pleasant way?
The International Dark Sky Association has material on its website that is specifically directed to that. Yeah. So that's where I would go, the IDA website. The International Dark Sky Association is an organization in the United States which has been very effective in creating light standards that are dark sky friendly and incorporate the kinds of features that we're talking about. They work very closely with the lighting industry, and in Canada we've had some reservations about particular aspects of the agreements that they worked out. But in overall, they've been very, very effective and they do very good work. International Dark Sky Association. Anybody else? Okay, thank you very much.
All right then, so we're going to then wrap things up with our president, Dr. Ralph Chu, who's going to give us a few announcements.
Okay, thank you very much. Right. So, Okay, so our next meeting then, this isn't advancing properly.
I'll have to do it manually.
Yeah, okay, you can put up the next slide. So our next meeting is going to be the August Recreational Astronomy Night, and it will be in 3 weeks' time. Okay, on August the 9th, and we'll have Dennis Gray finally come in to do the sky this month. We did bump him for this evening in order to accommodate Dave Makepeace, and Dave, that was a great movie. Thanks very much for doing that. Okay, other things that we will have for that evening, Ron McNaughton is going to do a reprise of his presentation at the General Assembly on how ancients predicted eclipses. And then we do have one open presentation slot, so if anybody would like to do a presentation that night, please contact Paul Markov, and he'll be very happy to hear from you. And hopefully that'll fill out our slots for that evening. And again, the reason why we're doing this is because in the normal course of events, we would have been meeting on August the 16th. The only problem is there's a lot of people who are going to be taking off for the eclipse, and August 16th is just a bit uncomfortably close to a lot of people's departure times. So we're just moving it a week ahead to make sure that we get a chance to get together before everybody gets out of town. Okay, so next slide, please. We do have our regular observing being scheduled as well over the next few weeks. So solar observing will be on Saturday, August the 12th. And again, in the summertime, because of the holiday weekends and so on, we've got to move around from our normal date on the first Saturday of the month. And so our regular date will be the 12th, and I guess the backup for a cloud date is the 19th, when everybody's gone.
The backup is me, I'll probably be the only one there.
Yeah. Well, anyway, we'll see what happens about that. Yeah. So, in any case, that'll be out at the front of the Science Center on the Telescape on 10 o'clock on the 12th. Okay, next slide. We also have our usual dark sky observing sessions and so on. So, dark sky next week, the first clear night of the 24th through the 27th. No, it's 2 weeks, sorry. And then the City Star Party, the first clear night on the week of 31st of July. And again, we will have go or no-go messages posted in our usual media, both on the website and through Twitter and on the Yahoo group and the forum. Oh, and by the way, again, a reminder to everybody who has been posting and monitoring on the Yahoo list. Remember that we are moving our official broadcasts of information over to the forum, which is on our website. The Yahoo group is not going to get shut down, but we're not going to be using it as much. We're not going to let it close down because of the fact that we've got so much archival material on it. And so that'll still be accessible, but the forum is our official email correspondence medium from now on our website. Okay, next slide, please. Outreach, we've got a lot going on over the next few weeks. So on July 28th, we have the Millennium Square Stargazing Night. And Arnold, I think I saw you here this evening? Yes. Yeah, okay, so Arnold is here. He's the one of the coordinators of that event. And he'll be happy to talk with you if you're interested in helping out. And again, we get a lot of very good response from the public for these events, and so please support it by turning up and showing off your telescope and helping out with that program. Next slide, please. Another big one, the National Star Party. This is something that's being organized by the National RASC as part of our contribution to Canada 150. It's also, in a way, the kickoff for RASC 150, because it's 1868, which was our founding year for the Toronto Astronomical Society, which became the RASC, and we're sort of using the National Star Party as one of the events that will sort of prime the pump for that event. And there will be other events going on throughout 2018 as well to mark RASC 150. We will be holding the main event here at the Telescape at the Science Center, but we also have something going on in cooperation with the Dunlap Institute on the University of Toronto campus. So any of you who don't manage to make your way up here to the suburbs, if you're in the downtown area and want to do something local, certainly you can go participate in the Star Party at the Dunlap Institute site on the U of T campus. Okay, next slide, please. Okay, and then of course there is the solar eclipse on August 21st, and it is going to be about a magnitude 0.76 here in the Toronto area, and for Toronto, the peak magnitude is at 2:32 p.m. on the afternoon of the 21st, and plus or minus a few seconds if you're up at the CAO or whatever. So we do have 3 sites that will be running for that, and again, this slide will be up on the 9th of August as well, but we have agreed to run something here at the Science Center as well as at the Dunlap Institute on the back campus, and as well we do have a small group that are going to be doing a public program at the CAO. All 3 sites are going to need to be supported by those of you who are not traveling to the Path of Totality, and again, we'd appreciate it if you could help us out with that. Please contact public education at rascto.ca to let us know if you can help us out. Okay, next slide, please. The other thing is the Carr Observatory, again, open, and everything is running well there. So again, remember that you can reserve online to get sleeping space, and it's open every weekend now. Supervisors are on duty on every weekend except for full moon weekends, and during the week you can also go up, although the supervisors will not be there to open up the GBO with the big telescope. But if you have your own instrument, you can certainly go up there and use the THO to set up. Okay, next slide. Another membership privilege is our telescope loan program for those of you who are here for the first time. This is a benefit of your membership, that we have a number of telescopes of various types, as well as an astrophotography setup that are available for you to rent free for 2 weeks at a time. And again, we have a couple of our telescope loan program managers here, Peter and Mark, and they'll be happy to talk with you if you'd like to get any information about that. Okay, next slide, please. And finally, the meeting after the meeting. For those of us who fast beforehand, it's really nice that we're done before 9 o'clock, because we'll actually have an early dinner tonight. And the rest of you can come along and help keep us company and enjoy a drink if you like. So that's at the Granite Brew Pub down at Mount Pleasant and Eglinton. And if you haven't been there before, there is an underground parking facility accessible from Mount Pleasant Road on the east side, just south of Eglinton Avenue. And hopefully we'll see some of you there this evening. Okay, that's it for tonight. Another announcement there from Peter Hiscock. Yes, Peter?
I have a number of Sky and Telescope magazines and RASC journals that I've accumulated over the years, and I've left them in a box outside the door, so if anybody would like to look at back issues of those magazines, please take them away.
Ralph? I have a quick question. I think I'm back the Wednesday, August 9th, and I want to know if anyone would be interested in hearing about research in the dry valleys of Antarctica, which is an analog for Mars.
No. Yeah, I think we just got our third slot for the...
I just heard, I heard a no and a yes, so I don't know.
Absolutely. most of you don't know it, but Professor David Nobes is an old friend of mine. He and I actually were on the Science Center staff back in 1970. We were part of the original student host group here.
The first, yeah.
Yeah, he was in the first group, I was in the second group, and he ran the meteorology station right below us, whereas I ran the astronomy program. So it's sort of coming back here is quite something, since it's been a long time since we were both here together. Anyway, so yeah, that'll be great for you to do that if you could for that meeting. Perfect. That's exactly what we could use. Okay, Alan.
Okay, as a follow-up to the solar filters, I did put in an order for a large sheet of film, but unfortunately I won't be getting it until the end of the week. But what I can do is, if you want to arrange to contact me by email, it's possible for me to cut film and send it to you by mail. Basically, anything smaller than 4 inches can go into a regular envelope. Anything larger, then we'll probably have to discuss postage, but unfortunately, I'm flying out west Saturday, so that makes it awkward. So sending it by mail is really the only option for me, unless I can find someone who will handle it from this end. And I will. Yeah. Okay.
Okay, we can make those arrangements then to get that. And by the way, I do have some more solar viewers here. These are the RASC Eclipse shades, so free for the taking if you like to pick them up after the meeting ends. Okay, Ron?
I worked on a filter for my telescope. It's small, but I don't need the exposure. And it just comes out like that. So if anybody wants to look at the design after, if you think you're making an easy to remove filter, I'll show it to you.
Okay, thanks. So I think there's a lot more to go on, but unfortunately we do have to clear the building by 9 o'clock tonight. So any other announcements? Okay, I'll turn it over to Tom.
Okay. So just one final note with respect to the solar eclipse observing that will be going on here and other places in Toronto. We really will need help on this one, because we can probably guess there are a lot of folks who will not be available. The many of folks who you might expect would be our normal volunteers will be out of town. So if you are available, please let us know and please help out. And one other note is that you may have noticed that the sky this month was not presented this month, but it is going to be available online. Chris Vaughn has done all the hard work, and it will be on the website shortly. All right, unless there's anything else, then I guess we're done for the evening. So thank you very much for coming out, and have a safe drive home, folks.
I just mentioned